Welcome to Ask and Learn.
Hey, it's Clarissa and Numeraid here. So for part A, we have our given. We're gonna determine the limit of the ratios of the two functions using asymptotic. So limit as x approaches positive infinity for x squared plus 3x plus 7 over x squared plus 10. We divide the numerator and denominator by x squared, and we get, since as the limit as x approaches infinity for 1 over x and 1 over x squared both are equal to 0, we get 1 over 1, which is equal to 1. So f and g are asymptotic. For part B, with our given, we're determining the limit of the ratios of the two functions as well. So this is x squared log x over x cubed. Excuse my writing. We divide the numerator and denominator by x squared, and this is when we use the L'Hopital rule, which is part of calculus. So this is limit as x approaches positive infinity, 1 over x over 1. This is just equal to 1 over x, so it's 0. So we know that by the definition of asymptotic, these are not asymptotic. For C, we're going to determine the limit again of the ratios. So limit as x approaches positive infinity for x to the fourth plus log of 3x to the eighth plus 7 over x squared plus 17x plus 3 squared. We're going to divide the numerator and denominator by x to the fourth. So if we divide both of these, we get divide the denominator, and this is the same. Divide top here and divide by x squared. So when we divide the top and bottom, we get 1 plus limit as x approaches positive infinity log of 3x to the eighth plus 7 over x to the fourth all over limit as x approaches infinity for 1 plus 17 over x plus 3 over x squared. Square this, and we're going to use the L'Hopital rule on the limit above here, which is log of 3x to the eighth plus 7 over x to the fourth. So I'll put it right here, and this becomes equal to 1 plus 0 over 1 squared, which is just equal to 1. And by the definition of asymptotic, then we know that these two are asymptotic. For part D, I'll start up here. So we have our given, and we're going to determine the limit of the ratio of the two functions. So limit as x approaches infinity for x cubed plus x squared plus x plus 1 to the fourth all over x to the fourth plus x to the third plus x squared, plus x plus 1 cubed. We're going to divide the numerator and denominator by x to the 12th. So we get equal to limit as x approaches infinity for x cubed plus x squared plus x plus 1 all over x cubed, this is to the 4th, divided by x to the 4th plus x cubed plus x squared plus x plus 1 all over x to the 4th. And you cube this, and using the L'Hopital rule, you get this is equal to, as the limit approaches infinity, you get 1 plus 0 plus 0 plus 0 to the 4th all over 1 plus 0 plus 0 plus 0 plus 0 to cubed. We get 1. So by the definition of asymptotic, we know that f and g are asymptotic.